part. Okay? So, when you're done a run, you're going to have to clean this piece. So this comes off, you clean this, you clean this. This is red rubber, do not put solvent on it, otherwise you'll eat it up.
Okay.
Okay? You put this on.
What is the best way to clean it?
Hot water.
Okay.
You guys are using aqueous stuff here, right? You know, you're using organic solvent?
I'm not sure, maybe not.
Anything over 10% is going to be a problem for the system. This is an aqueous only. So you have 1, 2, 3, and you have 1, 2, 3. So what I do is I line up the first one and I put it in a bit. I line up the second one, put it in a bit. Line up the third one, put it in a bit. Okay? And just tighten this down. Okay?
Okay.
How often do we need to clean the rubber?
After every run.
Okay.
Otherwise you're gonna get crust. Especially if you're changing products.
Okay.
Alright. It has 2 seals. These are made of a product, a polymer called FKM, and they can handle some good solvent, but nothing over 10%. Okay? So you make sure your seals are in, and then this is plastic, this is metal. You can cross thread it very easily. So what I do is I go anti-clockwise until it drops in, and it's free flowing. Okay? And the same goes on this side. Anti-clockwise till it drops in, and then free flowing. Okay? So what I do is I have this loose, because this spring will put pressure on this piece to hold it in place. And this has to sit like this. Alright? So, Buchi side. I turn it so it's facing away from me. Okay? And I put this guy on. This I have at an angle that way. Slide this on, tighten it down. Enough that it holds. And I just check that the hole is this way. Okay. Then I grab here, and grab here. Flip it over, so now the hole is facing me.
Okay.
Okay? Put this on, push against the back, and turn that. Push this on, and then you slide this in, and turn that on. And then you hold, don't put pressure on this, hold like this, and you turn this. It's locked into place. When you want to take out, you loosen this. There's movement. Put your finger in here, release this, out. Loosen this guy. Voila. So you feed this one on first, then you feed this guy, and it's important to not lose that ring, and you feed this O-ring. Okay? So when you put this guy in, turn it so that it's almost tight. Okay? So that you can still pull a bit.
Okay.
Because if you leave this too loose, when you tighten it, it'll bring it in. So you want this tip to be right in the middle of this circle. If it's too close to this side, you'll get the wrong reading. If it's too close to this side, you'll get the wrong reading. You want it in the middle. And it's very crucial it stays in the middle, because if you put it in the middle and you run and you get an outlet temperature of say 80, and then she runs the same method, but because this is in the wrong spot, she may get 90, she may get 75, and then you'll be like, why is it not repeatable? So it's very important you guys have it in the middle. So you can look from this side, but I like to look from this side. So I will stick my head and I will go about there and I will tighten it down. Okay? See, it's in the middle now. When you're cleaning, you take it out. Just take this out. Up. Now, this is what's going to happen.
Yeah, exactly.
So
adjustment when I put inside.
if you measure and say, oh, it's got to be here,
Mm-hmm.
when you put it in and you tighten it, it's on the wrong spot because you have all that threading to go through, right? If you measure it like this, you have threading to go through. So it's always best to push this to the back
Mm-hmm.
and then go. So try it. Two notches round at the top. You put this in wrong, you bend a pig. It's important to get it right. Okay? If you ever fire up this unit and you get error 001, it's because this isn't connected.
Okay.
Basic error, everyone does it. Okay, so this is your collection vessel.
Mm-hmm.
This is known as a cyclone. Okay? Something to note is this seal. Flat, ridge. Flat, ridge. Okay? Orientation is important. If you put it on the wrong side, you will not form a seal. Flat side is always against this side. Ridge side is against the glass. Glass is blown, it's formed. They will always have a variation. So this ridge will bite into that variation. So, you put this guy on. Put the seal on. Quarter turn. Okay? Don't brute force it, quarter turn. Okay. Quarter turn, off it comes. Is because if the cyclone is here, you have to manipulate this behind. Okay? It gets very complicated. When you have this beautiful open gap here, do it first because it's always behind. Same thing with this guy. Ridge, flat. Ridge, flat. Right? The O-ring. This guy goes like this. And this is important. This always faces this, and this always faces the machine. You put this in, you do your quarter turn, and you go. So everyone stand on this side, and I want you to watch these three holes. Okay? Okay. So you put that on, so this is not that difficult to do. But you didn't get the joy of putting that one on, but you will get the joy of putting this one on because it's the heavier one. Now, this is a cellulose filter. Okay? This is a Teflon filter. They both work, but you don't put both on. You put one or the other. I will show you in the operation manual the section that talks about how to put this on, and you have to be very careful. Why would you use this over this? Simple. This thing will make particles between 2 and 25 micron. Cellulose will let stuff that is closer to the 2 to 4 micron through to your aspirator at the back. This will trap. So if you're going to do a lot of work on the lower end of the scale, use this, because this is not permeable. So the particles will stick on this, and then you tap the sides and they'll fall, and then you can collect what's in here as part of your yields. Okay? I don't like to put this on when I'm with a client, because once I open this up, it's done. When you take it off, you rip it. Note down the part number and order yourselves a couple. Okay? Because if you do end up using this, they're almost a one-time use product. Because when you're trying to remove it to clean it, it'll have got stuck, and then it'll just rip, and you're done. This
How long it has to be changed?
We'll talk about that when we talk about pressures. This guy, you should change every few runs. Take it out, wash it in a washing machine, air dry it properly. So put it in a dryer and dry it on kind of like your knits. Very soft cycle, so it doesn't shrink, but you want to get rid of moisture. If you don't get rid of the moisture, it'll build mold. If it builds mold, it'll block. If it blocks, life goes back. Okay? So, madam, please. Like this, okay? And you shove it on this fitting. Just tighten it down. Okay. Loosen. You pull it off. And then you put it on. And tighten it down. It'll be stiff at first, but as you start using the system, it'll thin out. Okay. So now for the hardest part in this process is connecting this guy to this. There's a lot of tension on that line, and especially the first month or two when that line is still cold, it's very stressful. And you're going to get frustrated, you're going to get very angry, and then you're going to do something stupid and you're going to cross thread. So if it starts struggling, walk away. Walk away for a few minutes. There is a seal. Well, here's the thing. If you strip this piece, it's $150 to replace it. Okay? You're doing phenolic cap on a cast aluminum piece. You're going to cross thread very quickly if you're not careful. I always tell people, you're going to fight, and I'm going to see you turn red today. Because you're going to be like, how the hell do we do this? Okay? So I'm going to show you a couple of ways of doing it, and then you guys can do it the way you want. So I personally take this guy off. I bring this guy over, and I do it this way. Okay? If you get 2 or 3 threads in, and it starts to bite, stop.
Okay.
You're cross-threading. You're going to strip it. Okay? There's a lot of tension on this line. So you kind of have to find your groove of doing it. And even when you're taking it off, it's going to slap out at you. Now, there is a seal here that is right there. Be careful it doesn't drop out. You will have to pick it out gently, clean it, and put it back. It is silicone, so it is Teflon. It's like a Teflon U, but the silicone inside.
Okay.
Okay?
Is there a special way to clean it or
You just pull it out.
Okay.
Okay. So these are the same. This is Teflon and this is silicone.
Oh.
You don't need to split this. Don't
Okay.
split it. Just take it out and keep it as one piece. Because if you try and split it, you'll bend the Teflon. You just need to wash this and clean it. Okay? So, everyone now, give this a try. As I said, you're going to feel a lot of tension on this line because A, it's brand new. 2, it's short. 3, it's very thick. So once you start using it more and more, the rubber will soften and become a bit more malleable. Okay. One of you guys can put the, why don't you put the cyclone on, please? Uh-oh, be careful. Actually, before you put the cyclone on, let's connect this guy back on. Connect the tubing, because we're going to need it. Exactly. And that clear tubing makes no difference if it goes above or below.
Okay.
It makes no difference to how it sits. I personally, I like to just make sure that this is in this. Okay. Good job. Okay. Now you can put that guy on. Perfect. Okay. So now we have this guy then. He's a bit different. Okay? He is silicone. And in actuality, this goes like this. So when we ship it, we put it here just so that it doesn't lose. Okay. So this guy comes like this. Okay. And it's head on, so this is still loose. And then we tighten this down. Okay. Let's get it off. What's up with the O-ring? Is that bad?
Huh?
Pinched a bit. It'll flatten back up. You have to have it there.
Yeah.
Because you're spraying, you will create static electricity. So this grounds this chamber out. Last, this is what we call a liquid trap. Loose, slide it on. Crank it in. Voila. Okay. So we've installed and removed glassware. Now we get to heat up the system. It's called a two-fluid nozzle. Fluid 1 is your gas. Fluid 2 is your feed. This is for nozzle cleaning. And this is for those rare applications where you need to heat or cool this chamber. Most people don't use it, only in spray chilling.
Which one? This one?
These two.
Oh,
This isn't
okay.
for spray chilling. You can pump cold water or hot water, especially if you've got like something a bit more viscous, then this will do it. This is known as the nozzle tip. Okay, there's a nice O-ring there. Needs to be changed from time to time. This is known as the nozzle itself, and this is the needle. That's the needle. Whatever you do not crank this because you will throw off the hoses.
Oh.
So you crank the top piece. Okay. There's an O-ring there, and there's an O-ring down there. No, sorry, there's no O-ring there, it's here. So this goes in, tight. There's an O-ring there, this slides on top. So air comes from the outside and goes through those channels. Your liquid comes from the center. And then it comes out here. You see that little red ring at the bottom? That is ruby. That is ruby. Because if you didn't have it, then your spraying process would eat away the sides of the stainless steel. So the ruby protects it. Okay. So your nozzle, you have thick and thin. The other ones are here. These two can go on because we don't need them. We're not doing cold water in.
Yeah.
Okay. So you have two hoses, one on this side, one on this side. The one on this side goes to the gas side of the nozzle. So you take this big
Do
guy.
you have some mark over here? Where is
Yes,
the
it says gas.
feed and gas.
So-
Okay.
So this should be in front of you.
Okay.
Okay.
And you squeeze this on top.
Left side left, right side right.
Okay. This guy is for nozzle cleaning.
This one goes on.
On top.
Yeah.
Goes on the top. Okay. When you put the nozzle in, you have to hear that. Okay? So, while that's going on, let's fire this guy up. So, I'm going to switch this guy on. We're going to drop the inlet down.
Okay. Before we start, what we have to check directly after just switch on?
You just have to set your parameters.
Okay. Do we have to check something here?
We will.
Wait,
Hold
wait.
on.
Before we turn it on.
Okay.
Calm down. It takes a while to heat this up. So, we're going to heat this to 200. Maybe not 200, that's pretty high. Let's go to 175. Okay. Now you see how this will not switch on and off because the aspirator needs to be on first. So the aspirator sounds like a turbine. It goes from so, see the needle is between minus 60 and minus 70. Let's just check all our fittings are nice and tight. Okay. So that is good.
Okay.
As this gets blocked, this number will go up higher. So you need to watch for it. It has to be between minus 50 and minus 70 is the ideal position because when we start pumping air in, this number will change a little bit. Now that we have the aspirator going, I'm going to lower it down to 50 so that I don't have to shout over it. Okay? Now I can switch on the heater. This dot is telling you it's heating. Off, on.
Okay.
Okay?
Some more picture.
If this dot flicks to this side,
Yeah.
there's something wrong here.
Okay.
Because this line is very flexible. Okay? Could also be the board, but most times it's this guy. That's the problem. Okay? So while this is heating up, let's talk about how we're going to feed. Okay? So, what I do is this guy stays on this side. Okay? And he's just there to prevent the line from being pulled through because it's a peristaltic pump. Okay? So, first thing I'm going to do is I'm going to measure . This comes through this, through the bed, to here. Okay? So I'm going to leave a bit of slack, and I'm going to cut it. Where's my knife now? So what I do is I like to do it this way. I put this guy here. Clips on this side, and clips on this side. Okay? Okay? So now we have a whole bunch of tubing here. So I always kind of this is a peristaltic pump. So it works on the theory that these rollers squeeze the tubing to displace air. 3 o'clock, 12, 3, 6, 9. 3 o'clock is open. 6 o'clock is not closed properly. 9 o'clock is closed properly, and you can feel it. It doesn't latch here, it latches there. 12 o'clock is partially open again. Okay? So 3 o'clock is open, 9 o'clock is closed. Everyone get that feel.
So what does an aspirator do?
It's just pulling a large amount of air.
Yeah, right?
So as you can see, when I lowered the aspirator, it was lower here, right? At 100%, we should be between negative 60 and 70. As you lower this, then it'll change, right? So sometimes you won't run the aspirator as hard, and sometimes you will. It all boils down to what you want to do. We're getting up to temperature, so I'm going to up this a bit. This is a ball. So you have upper and lower. You read in the middle. Not at the top of the ball, not at the bottom of the ball. So if you want 30 millimeters, the middle of the ball should be in the middle over there. So for example, this is not 30. This is 30. The middle of the ball. Not the bottom, not the top. It's very important you guys all find that out now. Because if you read 30 as the top of the ball, if she reads the bottom of the ball, you're going to be all over the place as far as your products go. Okay? You may want to put that down. Okay? So I'm going to run it at 40. Start off at a lower front. Okay? That's normal. It'll start and stop. Okay. So I'm going to put my thing in. Now, when I start spraying water, my outlet temperature is going to drop because I'm going to lose heat. You see it's coming out there?
Yeah.
Now, why is it pulsing like that? Because that is not providing enough constant flow. Okay. If I reduce it, it might be a bit better. But we're not getting a good stream. Alright? So we're getting a good stream. You can see my outlet temperature is dropping pretty hard. If you notice something, if I increase or decrease this, the cone goes wide. Yeah, I don't like that because There we go. So we have a much better. So I just adjusted the bed. So this adjusts the bed, how much pressure this puts on the tubing. Okay? So,
So we can
So you tighten
adjust
it?
but our own, yeah?
sorry?
We can adjust it by ourselves, yeah?
I wouldn't.
Okay.
Unless you start seeing that pulsing.
Yeah.
But generally when you get that pulsing, the tubing has weakened. So you have extra, just cut new tubing from here to here.
Okay.
Okay? So you can see we're spraying. Now, we lost a lot of heat, so I'm going to dump this up higher to compensate. So the higher the airflow, the more you spray, the cooler this will become. But we're getting a very nice cone there, and I can adjust it based on these settings. So if you look up there, can you see it? Can you see that little cone? Now look what happens when I increase the air. See how it's more pronounced? Can you see how it's more pronounced? So we're not hot enough, so it's creating droplets and grabbing here. So this is why it's important to have the right voltage, right? But air has also a big factor because you're dumping cold air on top of heating, right? So you gotta be careful. So we're just gonna let this run, and when you're done your run, I would move this into clear liquid, whatever your solvent is. So in this case, this system is designed for aqueous solution, so clear DI water. Spray some DI water. So you may have to up the temperature to compensate for that water. And then when you're done, pull the line out. You can see the bubble traveling. And then when it disappears there, then you can switch off your pump. And then open this up. Okay? So I'm going to switch off the air because I don't want that thing to kick on. Can you flip the lever forward? Okay. So we're just going to keep heating the system so that we can evaporate the water off that we have stuck to the side. Laminate this, post it onto the side so that you know that this is the start of the Buchi mini spray dryer. There are two sides to this document. This side is for the other attachment which you don't have. This is your quick start guide. Please paste it onto the side. I don't care if you have it over here. Laminate it though because it's going to get dirty. This is your best friend. If you've never done spray drying, this is your best friend. Parameters are explained at the back. It's graphed in the front. Laminate this, because you're going to be looking at this quite a bit over the next few days. I can send you a soft copy, but it's never going to be this nice and colored. Okay, so everything that we can adjust has an effect on something else. The effect has great, moderate, very little effect. The size of the arrow determines the effect and the color code here. So for example, if I increase the aspirator, my outlet temperature will also increase, but my humidity of the final product will decrease and my yield will go up. Humidity of the drying gas. Well, the humidity of the drying gas has to do a lot with this. So you need to get some coalescing filters, because this is going to pull in whatever atmosphere is in here. So if it's humid in here,
What air filter?
you need coalescing air filter.
Coalescing air filter.
Right.
Okay.
Coalescing air filter has three components to it: a charcoal to remove hydrocarbons, It has a dryer and a membrane so that you get dry air. So this will add a lot of liquid. So my recommendation is drain it on a regular basis. This will fill up with liquid. Inlet temperature also has an effect. But if you notice, aspirator humidity and inlet temperature have no effect on particle size. What has effect on particle size? Spray gas. If I have a higher spray gas, I'm pushing more air, I'm going to create a finer cloud of particles. So I'm going to go small. Feed rate, too slow, too high, will also have an effect on particle size. Because if you're feeding at a slower rate, then it's going to make bigger bubbles. If you're feeding at a faster rate, it's going to make smaller, and then you add air on top of it, right? Remember, 2 to 25 micron. From the moment the droplet hits there to you collecting powder in here is 1.5 milliseconds. Sorry, no, 1.5 seconds. Not milliseconds. I apologize. I was thinking of something else. 1.5 seconds. So if your product is thermally unstable, you got to remember one thing. It's not going to see that high temperature for a long period of time. 1.5 seconds is nothing. So this is cool. It's warm. I mean, there's nothing in here, so it's a bit hot. But this is cool, right? Okay. So please understand these parameters and use them. The beauty about spray drying is you can take any application node out there and you can pretty much reproduce it on our system. You got to manipulate a bit here and there. All right? Operation manual. It's written really well. It's not in Swinglish. It's actually in English. Error messages, troubleshooting. How to clean the aspirator. You guys are using a lot of maltodextrin, a lot of to clean it. This is how you clean the aspirator. I want you to do it once a month. Especially when you're pushing a lot of product through, when you're doing a lot of R&D work, once a month. And then if you're doing a big project, at the end of the project, you clean the aspirator if this thing is going to sit for months on end without usage. Because it happens depending on your projects. Because if you don't, the maltodextrin is going to gum up the aspirator. And then you're going to switch it on and it's going to start blowing fuses because it can't rotate because it's all stuck. If you clean it at the end of a big project, then you don't have to worry about what's going to happen the next time around, right? It's kind of like doing a regular oil change on your car.
Used to my mechanic do it, so.
Well, you're going to learn how to do it yourself. Okay? Optimization of processes, end of spray process. Photocopy these page. Recovering particles off the outlet filter. So when you are doing the Teflon, this is cellulose, the other one is Teflon.
Bless you.
Excuse me. So what you do is you connect one of the air lines and you just pulse some air in and it'll push the particles off. Okay? This tells you at the aspirator can go minimum of 50 and a maximum of 100. So at 50 and at 100, what the graph is as far as volume of flow. Okay? So you can know that because some app notes are written based on a particular volume of flow. Some are, so you can use this chart to convert it over to know what aspirator setting to set at. Okay? Peristaltic pump maxes out at 30 mils a minute. We're in percentages. So you know 10% is X, 20 is X, whatever. So you know what your feed rate is. The peristaltic pump is your feed rate. So when you're reading an application note and it's saying a feed rate of X amount, this is how you know. This shelf is designed to handle a bit of weight, so people will often put a stir plate and a stir and heating plate on this, because if their formulations come up, then they'll keep them warm and stirring for the spray process. Especially if you guys start doing hemp and cannabis product, because I overheard your conversation, you're going to be using a high molecular weight polymer called collidon. Collidon solidifies if it's left sitting, and it'll also break out. So you need something, so you can put an adequate size stir plate on this, no problems. Okay, this is why we have this awkward design, is this shelf was designed to handle a stir plate. That's the reality. Outlet filter installation. This will talk to you about how to change from one to the other. There's some key things you need to watch for, even on when you're doing the installation, especially of the Teflon membrane. Note, okay? Now, that's done. So we've gone over all of these factors. We've talked about the nozzle. We've talked about things you have to do. You can see this has started to evaporate and dry out. Now, when you're done your run, you switch off your heat first. Okay? Why? Because this is going to be hot. I don't know about you, but I don't like burning fingers. If you want to cool it faster, bring in some air. Okay? If you want to, and then just let it glide down. When this reads about 50, then you're okay. Again, it's up to you. Remember, it's your fingers and it's your health, not mine. So I like to have a shower with water at 70 degrees. My wife hates it. Whatever your preference, be comfortable. Anubhav? From the local safety store, buy those gloves that have rubber tips. Okay. They're insulated gloves for rubber tips. That way, if you're handling glassware at 50, you're not burning yourself, but the rubber tip will give you some friction to all the glass. Okay? Do not scrape this stuff. Okay? There is a special coating on this glassware. So how do you clean this? How do you empty out your product? Well, from here to here is viable product. From here and here is not viable product. That's the way I look at it, because I don't know what's going on. Okay? Here you can, and sometimes once it's cooled, you can take a little, you know, those spatulas you get at the dollar store, the plastic ones, just gently tap. When it's cold, not when it's hot, and it'll drop the product down. VWR is the only place I've seen this. They make this long piece, it looks like a squeegee, but it's only that wide. So you can use that as well, and you can shove it in and scrape to remove the stuff off here. When you're washing this, be careful of that tip, because you're going to wash in the sink over there and someone's going to slip it and it's going to break. So you can get those rubber mats that you put inside the sink. Go to the dollar store and just buy those. They're cheap, but they work. So it'll give you a bit of cushioning at the bottom. You're going to make sure you don't break that. I've got too many phone calls a week later saying, oh, the glass broke. Okay?
How much they are?
$6,000-$7,000.
Wow.
Is up there. I don't, again, you know, be careful. Just take your time on it. There's no rush here, okay? You're an R&D facility. That's it. You know, just don't rush it. If you rush it, you're going to make mistakes. If you spray and you find that you're hitting one side or the other, check your nozzle. Did you clean it properly? Did you dry it out properly? The other thing is when you're cleaning it, that needle sometimes bends. If it's bent, it's going to affect the flow. Now, one thing we didn't talk about is this. The nozzle cleaner. There are 5 settings on it. You can manually pulsate it and you'll see it block flow. Okay, so you see my flow coming. See how it's breaking it temporarily. Come closer, I don't bite. Can you see it? Okay, and all that does is it pushes that needle down and then pulls it back out. 1 is longer intervals, 2 is shorter, 3 is shorter, 4 is even shorter, 5 is pretty quick. It's just bang, 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 bang.
You have to keep it or no, just press one.
Only if you need it. Okay.
Only if you need it. For example, if you're doing, for example, chitin or something, which has a slightly bigger particle that can block down. So if you are seeing that it is getting blocked, then you use this. That was the biggest disadvantage with that one, with the older system. It didn't have a lot of cleaner.
Right. So, viscosity, 700 centipoints. With this nozzle. With this nozzle, it's 700 centipoints. We have another size, it's bigger. You can go a bit higher.
Okay, 720 points. Okay.
That's your viscosity limit on this machine with a 0.7. Now, let's get one thing clear. The size of the nozzle, this is a 0.7, we have a 1.4, does not mean the size of your particle. It has to do with viscosity of your sample. Size of particle is controlled by feed rate, spray. This is your biggest factor is right here. Okay? Lower this down. Switch this up. Switch that off. Alright? Questions, accusations, things you want to throw at Anubhav, I'll answer. No. Questions? There's a lot of information that has gone through you guys.
Okay, before
Please read this.
Okay.
There are very important sections in this manual that will help you through the process, especially the spray drying process, how to start, how to optimize. All of these is discussed in here very nicely. You were going to ask me a question.
Yeah. Now, what does it look like? This, what we have to do before I start the first experiment? Do we have to clean this part or just?
Well, I don't know. Do you clean your dishes before you eat the next day? You're a university student, maybe not, but I do. You do. I mean, you can look at it. It's simple. Cross contamination.
Okay.
Okay? Cross contamination. If this is dirty, your yield is going to get affected. Not only by the previous product, but it's also going to reduce how much it shows. Alright? So if you want to have some fun this afternoon, salt in water, put it on, and watch it spray, and you'll see a nice cycle. Okay? Then you can clean it after that. Yes, clean, 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 clean. And your nozzle is very, very important. If your nozzle is not clean, it will not let enough air through, and then you will have back pressure issues. All right?
So they will soon replace this one with an in-wire building line.
If you're going to get the building line, make sure you have the triple filter on it.
Okay.
You need to get a dual stage regulator.
Dual stage regulator.
Dual.
Okay.
The reason why you do a dual stage regulator is because In a dual stage regulator, it compensates for the drop in pressure on the backside. Because when you're running and someone else down there suddenly opens their valve, you're going to get a drain, right? Path of least
So
resistance.
the dual stage regulator will come with the. So where is it installed? Here on this side or on the back side? Of where the compressor is.
Wherever you have your airline coming in.
Okay, so this is something like on the client side, right?
Right.
Yeah.
So whenever they plumb it in and bring it wherever they want,
And then we will install that.
coalescing filters.
Is it something like this? I have another equipment.
Okay.